All right, these are the video solutions for homework 38 for calculus. So this is a handout that was provided through Haiku, and there are multiple pages to it, but let's start with number 1. So number 1, we are given a graph of f prime of x. So this is a graph of f prime of x. So please don't forget, as we just said twice, this is a graph of f prime of x. So I'm going to make sure that I know that. I'm going to label it. So in the same system, let's sketch a possible graph of the function and of the second derivative of this function. And we want to make sure we label those. So we're given a bunch of points that exist for the function. If you notice, there's no primes here. So these are all the functions. So I'm going to go ahead and take my blue, and I'm going to just start by marking all of these points. Now all of these points are part of the function. So I have f of negative 6, 0, and 5, which are 0. So that's a point here, here, and here. And then f of negative 2 is a positive 4, and f of 2 is a negative 3. So I have all of these points. The question is, how are they connected? So just like we did in class, I'm actually going to start by going through this and talking about f double prime. So what I'm thinking of here when I'm talking about f double prime is I'm looking at the slope of my f prime of x function. So I'm going to talk about the slope of this red line. So if I look at the slope, for this entire section on the left, it is a negative slope, and that negative slope is decreasing. Then once I get here, I have a really weird situation. So this right here is what we call a cusp. You might have seen one of these before. And so it's kind of undefined. Your slope is undefined at this location because you can't really say it's 0, even though it looks like it kind of curves. It actually just kind of meets at a point. So it's undefined slope at this location. Then on the right-hand side, we have a positive slope. It starts very positive, but as we move to the right, it actually decreases as well. So how does this translate to an actual graph? Well, I want to have a graph of my second derivative that is negative and it is decreasing. So I start negative, and so I can estimate here. The slope here is about, let's say maybe negative 1/2 or negative 1/3, something like that. So I'll start about right here, and I will decrease from this point up until the point where it is undefined. So I'm going to go down, and it's kind of like a vertical asymptote. That's not quite as down as I wanted to go. There we go. Let's try this again, one more time. So we have something kind of like a vertical asymptote, and it's undefined at the y-axis. And then on the other side of the y-axis, we have a very positive slope that decreases over time. So we have something that kind of looks like this. So you have something that's kind of hyperbolic when we're talking about the second derivative. So just in case you've forgotten, this purple is the second derivative of the function. So that's f double prime of x. Now I'm going to go into my blue function, since I've given all of this, and look at every piece of information that I can get from the slope and from the second derivative. So first I'll look at the slope of the actual function. And so I look at the first derivative to talk about slope. So at this location, I have the first derivative equal to 0. And so at that location, my slope is 0. The same is true over here. The slope at, not quite, at this location is 0, because that is where my first derivative is equal to 0. Right here in the middle, it looks like it's negative 4. So my slope is negative 4 at this exact location. And then it is positive, but decreasing. And then negative and decreasing. Here it is negative but increasing, right? So because I'm going more and more positive. And here it is positive and increasing as well. So why do we need the increasing and decreasing? Well, we can actually just look at our second derivative here to kind of link that together. To the left of the vertical axis, I have a decreasing slope. I also see that my second derivative is negative this entire time. Well, what does that matter? That means that my function is concave down for this entire range of values. On the right-hand side, my second derivative is positive, which means my function is concave up, right? I see that my slope is increasing. So how does this translate? Well, for the entire portion here to the left of -6, I have a positive slope, and that positive slope is decreasing, concave down. So it's positive, but it's concave down. So positive slope that is concave down. So what does that look like? Well, it looks like something like this. And then it's still concave down and increasing up until here, where it's 0. And let me try this one more time. So I'm going to go up to this point. Then it is still increasing, concave down, and then it's 0 right here. And then it goes down into this point, right? So it goes through 0, then all of a sudden has a negative slope. So in the middle, what happens? Well, it goes concave down to about a -4 at this exact location. Then all of a sudden it switches to concave up. So we're concave up, concave up, concave up. And then at this exact location, it is a slope of 0, so it's horizontal. And then I continue concave up, concave up, concave up. Let me try this again. Concave up to this point, and then I'm still positive slope, and concave up, so I just continue up like this. So there is my function, and these are all of the bits of information that went into graphing it.